Hello everybody and welcome back. So in the last part we made this car and it's animating. So it's going to be this crash into the wall and it's 150 frames. And we did this in Houdini and this is the part that we made to make it work. And in this part we're going to start to break the wall. So this is the ref wall. So we're going to do ref wall. And this is the car we're going to use later down here for breaking the wall. So the first thing, we need to have RBD material fracture. So this is a super powerful node. So now you actually see it's kind of fractured it for us. And here you can choose material type and we're going to keep it to concrete. And you see fracture levels. We got 1, 2. So it actually do fracturing 2 times. But we're going to just keep it simple and only use 1. And here we can choose the amount of points. And you see the points, it's doing a really nice pattern, but it actually doesn't really fit our purpose because we want the car in the middle, so we want more points here, more small pieces. So we're actually going to do input points and use it for ourselves. We can use scatter seed here, but you see there is some kind of algorithm that doesn't make it in the middle. So if we remove this to 0 points and we actually do we have the wall here, and if we do grid, and this grid we want it to be standing, so we need to change it to XI plane, and then we just do a match size, and if we plug it in here we can do some settings, and if we reference to the wall we can do scale the wall to fit. So now it's kind of fit, but it maintain its scale so it doesn't skew. And then we're gonna do uniform scale, but we're not gonna use uniform scale. So now it's actually matching the wall really good. So it's in the center and it's also working good. And the reason we want this is because we're gonna do a scatter on it, do a lot of points. And there is no reason to have a lot of resolution on this one. It could just be a simple quad like this. So the points here, we're gonna lower it to, let's say, 18. And if we plug in 18 to extra Veroni point slot here, now if we do input points, you see now we can control it ourselves. And of course, there is a lot of different properties we can do. And we can actually work a lot here to do a lot of interesting patterns. But we're going to keep it simple and have it like this. So let's do 80 points. And in this one, we see, it's off. That's good. So what you could do later, eventually, when you're happy with the bricks, you could add some detail size here. So edge detail will crack up it like this. Now you see it's more cracky. But we're gonna, it's faster to work without it. So we're gonna add it later. And this is the first step. So this is super nice. So actually, if we do an RBD explode view, and here, you can see all the pieces, and this node is actually doing a lot of nice stuff. So here, if I'm middle mouse click on it, we can see it has some properties and prim attributes name. So it's 80 names. So for each piece there is a name. So at the moment we have 900 points. And if we look here on the primitives, we have name. So you see piece 0, the first 7, 8 pieces has piece 0. Then it's piece 1 and 2 and so forth. So eventually later, this is going to pack it into points to be really effective to simulate. And you also see here we have this one. This one is actually the middle purple one is doing the connections between all the points. So this is the constraints that keep the wall together. So and here you can, in the constraints, you can change the primary strength of it and so forth. So you can just have it, if we do, yeah, I'm gonna remove these parts and I'm gonna show you RBD solver, what happens. So at the moment, if we just plug it into the RBD bullet solver and do, yeah, play down here, you see it falls down. Because we need to add a ground, and we can do that in the, let's see, collision ground type. So here we add a ground plane, and if we play now, it's actually standing. And the reason it doesn't fall apart is because of the constraints. And if we lower the strength to 0, it should actually break apart of its own gravity. So that proves it works. I think it was 10,000. So this is super nice. So just to make this work, we have the car here. And if we look at the car and animate, it's actually not moving. That's because this is the moving part. And we need this part to be here. So a really convenient way we can do it, we just do right click, actions, create reference copy. So as you see here, everything is green. So it's actually transform 4. It's actually referencing to this transform 4. So actually, if you just do moving, you see it changing name here, right? So we just put it here. These two are kind of copies of each other. So that's nice. So now this one will animate the same way as the FBX file. So if we plug this into the collision geometry here, and we play, you see nothing happens. And the reason for this is, even though this car actually animates, you need to, in the RBD bullet solver, you need to collision type. I find it very strange that animated is not the correct one, but it's deforming. That's going to be the correct one. So deforming is the thing, and now it works, right? So you see, because of the constraints, it acts like a plane and it's going like this. And if we were up here, change this to, let's say, 3000. Yeah, you see more pieces are going off. So it's actually not holding up as good. So, but let's give it to 5000 now. And we want to kind of constrict a few pieces here not to be moving. And the way we can do this is to use another really convenient node that's called RBD configure, like this. Whoops. All right, so here we have it. And in this one, you see there's a fourth input here. And what we could do, if we just do a box, and this box gonna represent So you see all the lines here. Actually, I do a wireframe. So this box, if I just cover these areas here, so you see all these pieces are covered. I can do all the way up just to prove it. And now, if I plug this part in here, we can here do, let's see, I think it's this easy. So we're going to do what's active. All right, use bounds. So I think use bounds is the bounds that this box has. And if we now, so what's happened here is that here we made the points and the name right. And we have a lot of points and stuff. But down here in the RBD configure, it actually do this same thing as here. Do the assemble thing that we made for the FBX file. And it's actually doing points of each piece here. And it's actually, it's doing more here. It's doing, so this one here is the name and points. And actually the constraints here is just lines that represent a lot of constraints tag and constraints type. You can have springs and different things. So let's say if you do cloth and stuff, you don't want stiff constraints, you want more relaxed ones, and you have rest length and strength and so forth, a lot of stuff. So this node do a lot of nice stuff for you, and you can do this manually. So this is inside of the node, there is a lot of stuff going on. So thank you for these cool nodes, Houdini. And now, so what we made, this box, show, make a selection that's going to be able to move. So what happens here, because the sides are stiff, they are kind of static, it actually not moves and it turns out as we want it. So this is good, and we're going to tweak this. So we're going to just leave the wall as it is for now and make sure we get it into Unity and make it work. And this is going to be out sim. And I'm actually going to just copy this node, Control C. And then I'm going to do a ROP network down here and go inside. And here we're going to do a VAT Labs Vertex Animation Textures. So this one is a really nice node. And first off, we're going to have the input geometry. I'm going to paste the node that we had. And you could also just go here and pick out sim, of course. And first off, we're just going to solve what's going on here. So if I middle click, rigid body dynamics, expect point attributes, pivot and orient. So here you can see on the input, here you see packed geometry require position, pivot, and orient. But we are missing those two. And we can see it here. We have point, velocity, and I'm not sure about what this represents, but it's there. And in this solver, we can have in the output here. And if we open this one, then we can select a lot of stuff here. So this is everything that's used in here. And then it's only output a few stuff because otherwise everything is going to be heavy to work with. So here we just add orient and we add pivot that it asked for. So if we go in here, now it's happy. Super nice. So we're going to just change a few things here. So here we're going to have rigid body, and it's going to be Unity. And this one we're going to change to 150 because I'm aiming for 150 frames for this animation. And in the settings, we're going to leave this as it is. And here it says input geometry is cached to integer frames. So what this means is you could do like this. File cache. So let's say you have a big house with a lot of complicated stuff, and this simulation takes 15 minutes. Then you want to file cache this. So in this example, I would just do. I wouldn't do versions. I would skip this part, and I would base name. I would do wall, and I would do the word geometry. I would do cache folder for wall, and then I would do frame range 150, and yeah, and then save to disk. So now it's a very simple simulation, so it's quick. So here you have it, cache folder for wall, and we have all the frames. But because we are doing such an easy and small simulation, we don't need that one. So we're going to go in here and skip input is cached. And now it's actually here going to tell us to do cached, but I don't know to do it because we have such an easy thing. But now you know how to do it. And the texture is, if you want to know what kind of size you want, you could think, in this case, we have 80 points and we have 150 frames. That means that the texture size needs to be 80 times 150. So we will be fine with 256 by 256. But it's not a big deal. You can definitely have a big one, but if this is how it works. And we're going to keep the texture as it is. So the input has what it needs. Export, we're going to put the export not in a subfolder. I'm just going to keep it next to the hip file. The asset name, I'm going to do a wall. And include geometry. We're going to have not colors. We're just going to do geometry, position, and rotation. And this is good. I'm going to leave this one on because then it will create the material for us. And this one, group files into subdirectories. I don't want it to put each thing in their own subdirectory, so I'm going to untick it. Advanced, I leave as it is. Target engine, and I'm going to leave this too. So if you haven't installed the unit package and guides before, you do it here. So you just click here and it guides you. So here you can pack installation guide. But I actually cover this part in in my first Vertex Animation Texture on my YouTube channel, so you can check it out there. So let's click render. And you can see down here it works. And here this one pops up. So inside here we have the wall mesh. So I'm just going to move the ref to the side. So here we have the wall, and it's super tiny. And you should not scale this one up because the wall position will do it for us. Well, actually, more correctly, the input settings will do it for us, because when you install the side effects Vertex Animation package, you also have the presets folder, and here you have some presets. And if you don't find them, you can just copy and then you paste them in your assets somewhere. So I actually pasted them here. So these are the ones that I put here, and you need them. Let's see, where are we? I'm gonna go to, we are over here. So this wall mesh, let's see, yeah, so this wall mesh, if we tick this setting button here, we do pick this presets, I would say. Actually here, well, I don't know, presets. So this is the Vertex Animation Texture, import Houdini. So when I press this one, it ticks the boxes the way it should be. And then I do apply here. And now it's scaled up. And also the textures also need this one, a Vertex Animation import Houdini. So now we do some settings here. We're going to keep it. So now we have these imported the correct way. And the mesh, the lit material, we need this wall material instead. And the reason we don't see anything, because we need to plug in the wall position to the position texture and the wall rotation to the rotation. And here we have it. So now it's working. So we have everything kind of set up. And in the next tutorial, I'm going to start tweaking this. So we get it a little bit more detailed and control these pieces. So thank you so much for watching, and see you in the next one.